On April 10, 2019, a group of astrophysicists from the International Event Horizon Telescope Project, which is a planetary network of radio telescopes, unveiled the first ever image of a black hole. But could it be fake? Could it be that black holes are just a scientific dogma that no one has ever proved in practice? After all, no person would come back from a black hole and tell us how great it is there. What is a black hole? This term was introduced by the American theoretical physicist John Archibald Wheeler. He first used the term at a scientific conference 50 years ago. The theory of black holes began to form within the general theory of relativity. However, Albert Einstein himself didn't believe black holes existed. You can learn what's wrong with Albert in our other video, but that's another story. Since the black hole itself is invisible, we can observe only electromagnetic waves, radiation, and distortions of the space around it. The image published by the International Event Horizon Telescope Project shows the so-called event horizon of a black hole. It's the boundary of a super-strong gravity area, framed by an accretion disk, luminous matter that is sucked in by the hole. Let's give the floor to a recognized expert in the field of astrophysics, who will show us how else they like to depict black holes. Like this, 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 like this. But all these pictures that the respected expert showed are just a simulation. But we should explain how the image from the Event Horizon Telescope was obtained. It's because the distance between us and the object is just around 55 million light-years. They calculated that in order to see the supermassive black hole in the center of the galaxy M87, you need to build a telescope the size of the Earth. But we don't have a dish this huge yet. But there are radio interferometry technologies that increase the angular resolution. You can take two small telescopes and separate them at a distance of 300 feet. If they work together, their angular resolution will be equivalent to a large dish. The Event Horizon Telescope Project is no longer just an interferometer, but a radio interferometer with an ultra-long base, with telescopes located on different continents. And such a system has a resolution equivalent to a telescope the size of the Earth. The telescopes in the system were equipped with ultra-precise atomic clocks, equipment for faster data processing, or even atomic detectors, as in the case of the telescope at the South Pole. Atomic clocks are needed to synchronize data, because the telescopes are not physically connected to the network, and data on hard drives with a total volume of 5 petabytes were transported by aircraft to the processing center. But the virtual telescope still couldn't collect as much data as a planet-sized dish could. So, data was added during the rotation of the Earth from different points, and an increasing area of the virtual telescope was covered. But that's not all. Further, the received data went through several stages of processing by special algorithms. In general, the years of work of hundreds of scientists have given us this result. This is a supermassive black hole. There are also black holes created as a result of the evolution of massive stars. Over billions of years, the composition of gases and temperature change in them, which leads to an imbalance. Then the star collapses. A typical stellar mass black hole has a radius of 18 miles and a density of more than 200 million tons per cc. For comparison, in order for the Earth to become a black hole, its radius should be 3/10 of an inch. There is also a black hole in the center of our Milky Way galaxy, Sagittarius A. Its mass is 4 million times the mass of the Sun, and its size is 15 million miles, approximately equal to the diameter of 18 suns. Such a scale makes some people wonder, will a black hole swallow our entire galaxy? Not only science fiction writers have grounds for such assumptions. A few years ago, scientists reported on the galaxy W224605626, which is located 12.5 billion light-years from our planet. According to the description of astronomers, the supermassive black hole located in the center of this galaxy is gradually tearing it apart, and the resulting radiation disperses the incandescent giant clouds of gas in all directions. A galaxy torn apart by a black hole glows brighter than 300 trillion suns. But we can relax. Our home galaxy is not threatened by anything like this, at least for the next few years. Most of the objects in the Milky Way, including the solar system, are too far away from the black hole to feel its attraction. In addition, our black hole doesn't suck in all the material like a vacuum cleaner, but acts only as a gravitational anchor for a group of stars orbiting around it, like the Sun for planets. However, even if we ever fall into a black hole, what does it mean to us? The gravitational field around a black hole is very strong and heterogeneous, so all objects near it change shape and structure. The side of the object that is closer to the event horizon is attracted with greater force and falls with greater acceleration, so the whole object stretches, becoming like pasta. The famous theoretical physicist Stephen Hawking described this phenomenon in his book A Brief History of Time. Even before Hawking, astrophysicists called this phenomenon spaghettification. If we describe spaghettification from the point of view of an astronaut who flew up to a black hole feet first, then the gravitational field will suck in his legs, and then stretch and tear the body, turning it into a stream of subatomic particles. It's impossible to see a fall into a black hole from the outside, since it absorbs light. An outside observer will only see that the lucky guy approaching the black hole gradually slows down, and then stops altogether. After that, the silhouette of the object will become more and more blurred, acquire a red color, and finally simply disappear forever. But what's there inside? For obvious reasons, there is no reliable answer to this question now. However, scientists agree that the laws of physics familiar to us no longer apply inside a black hole. According to one of the most exciting hypotheses, the space-time continuum around the black hole is distorted so much that it forms a gap in reality itself, which can be a portal to another universe, or a so-called wormhole. But if this is a hole, which in other words can be called an entrance, or a portal, then what kind of mass can it have? Imagine for a second that black holes don't have any mass, which astronomers insist on, but are a channel to adjacent spaces, universes. And these channels appear at the junction of such spaces, which science fiction writers like to call parallel universes, although it is unlikely that there is anything parallel or perpendicular in that place. And if physically dense matter flows from our space to the lower one through a black hole, as through a channel, in the case when matter flows from the space universe above ours, the stars are formed, which, for that donor universe, look like black holes. And our black holes are stars for the lower spaces. An amazing picture, isn't it? According to the concept of an inhomogeneous universe, our universe is just a layer of cream in a huge cake of the matrix world, in which the universes form layers, each of which has a different dimension and is qualitatively different from the other. At the same time, layers of this pie differ in the number of primary matters. For example, our space consists of 7 primary matters, and the higher space consists of 8 such bricks of the universe. And below us, there is a universe with only 6 primordial matters. The contact of our space universe with the higher space creates a star, and we receive a stream of matter in the form of starlight. The so-called thermonuclear reaction is the disintegration of the matter of the higher space. That's how the stars light up. And the points where our space comes into contact with the lower space universe create black holes, which suck matter away from our universe. That's why black holes attract everything they can reach, although they don't have mass. This is simply the entrance to the closing channel through which physically dense matter from our space universe flows into the lower space. And all these winds, hair, and various rays emanating from black holes are just streams of other primordial matter. This is an image of the universe, where each space universe receives matter through stars, and loses it through black holes. At the same time, there is a flow of matter between different worlds. And right now, you yourself will experience a similar flow, but not of matter, but of information. All you need to do is go and watch one of the 2 videos, either the one in the lower space, or the one in the higher one. And may the radiance of billions of galaxies be with you. See you on Subversion.